In Chapter 2, we build a quick and simple Angular application. Small and focused examples allow me to demonstrate specific Angular features, but they can lack context. To help overcome this problem, I am going to create a simple but realistic e-commerce application. My application, called SportsStore, will follow the classic approach taken by online stores everywhere. I'll create an online product catalog that customers can browse by category and page, a shopping cart where users can add and remove products, and a checkout where customers can enter their shipping details and place their orders. I will also create an administration area that includes create, read, update, and delete facilities for managing the catalog, and I will protect it so that only logged in administrators can make changes. Finally, I show you how to prepare and deploy an Angular application. To create the SportsStore project, open a command prompt, navigate to a convenient location, and run the following command. The Angular CLI package will create a new project for Angular development with configuration files, placeholder content, and development tools. The project setup process can take some time since there are many NPM packages to download and install. Additional packages are required for this SportsStore project, in addition to the core Angular packages and build tools set up by the ng-new command. Run the following commands to navigate to the SportsStore folder and add the required packages. It is important to use the version numbers shown in the listing. You may see warnings about unmet peer dependencies as you add the packages, but you can ignore them. Some of the packages are installed using the save dev argument, which indicates they are used during development and will not be part of the SportsStore application. Once the packages have been installed, run the command as shown in the SportsStore folder to add the Bootstrap CSS style sheet to the project. The SportsStore application will use asynchronous HTTP requests to get model data provided by a RESTful web service. REST is an approach to designing web services that uses the HTTP method or verb to specify an operation and the URL to select the data objects that the operation applies to. Here I added the JSON server package to the project in the previous section. This is an excellent package for creating web services from JSON data or JavaScript code. Add the statement as shown to the scripts section of the package.json file so that the JSON server package can be started from the command line. To provide the JSON server package with data to work with, I added a file called data.js in the SportsStore folder and added the code as showing here, which will ensure that the same data is available whenever the JSON server package is started, so that I have a fixed point of reference during development. This code defines two data collections that will be presented by the RESTful web service. The products collection contains the products for sale to the customer, while the orders collection will contain the orders that customers have placed. The data stored by the RESTful web service needs to be protected so that ordinary users cannot modify the products or change the status of orders. The JSON server package does not include any built-in authentication features, so I created a file called auth-middleware.js in the SportsStore folder and added the code as showing here. This code inspects HTTP requests sent to the RESTful web service and implements some basic security features. This is a server-side code that is not directly related to Angular development. Every Angular web application relies on an HTML file that is loaded by the browser and that loads and starts the application. Edit the index.html file in the SportsStore src folder to remove the placeholder content and to add the elements as shown. The HTML document includes an app element, which is a placeholder for the SportsStore functionality. There is also a base element, which is required by the Angular URL routing features, which I added to the SportsStore project in Chapter 6. An important part of setting up an Angular application is to create the folder structure. The ng-new command sets up a project that puts all of the application's files in the src folder, with the Angular files in the src/app folder. To add some structures to the project, create the additional folders as showing here. Make sure that all the changes have been saved and run the following command in the SportsStore folder. This command will start the development tool set up by the ng-new command, which will automatically compile and package the code and content files in the src folder whenever a change is detected. A new browser window will open and show the content illustrated here. The development web server will start on port 4200. So the URL for the application will be http://localhost:4200. You don't have to include the name of the HTML document because index.html is the default file that the server responds with. To start the RESTful web service, open a new command prompt, navigate to the SportsStore folder and run the following command. The RESTful web service is configured to run on port 3500. To test the web service request, use the browser to request the URL http://localhost:3500/product/1. The browser will display a JSON representation of one of the products defined in this listing. Every Angular project requires some basic preparation. In the sections that follow, I replace the placeholder content to build the foundation for the SportsStore application. The root component is the Angular building block that will manage the contents of the app element in the HTML document from this listing. An application can contain many components, but there is always a root component that takes responsibility for the top level content presented to the user. So here, I edited the file called app.component.ts in the SportsStore/src/app folder and replaced the existing code with the statements as showing here. The @component decorator tells Angular that the app component class is a component and its properties configure how the component is applied. The selector property tells Angular how to apply the component in the HTML document, and the template property defines the HTML content the component will display. Components can define inline templates like this one, or they use external HTML files, which can make managing complex content easier. There is no code in the app component class because the root component in an Angular project exists just to manage the content shown to the user. And initially, I'll manage the content displayed by the root component manually. There are two types of Angular modules, feature modules and the root modules. Feature modules are used to group related application functionality to make the application easier to manage. I create feature module for each major functional area of the application, including the data model, the store interface presented to users, and the administration interface. The root module is used to describe the application to Angular. The description includes which feature modules are required to run the application, which custom features should be loaded, and the name of the root component. The conventional name of the root module file is app.module.ts, which is created in the SportsStore/src/app folder. No changes are required to this file for the moment. Similar to the root component, there is no code in the root modules class. That's because the root module only really exists to provide information through the @ng module decorator. The imports property tells Angular that it should load the browser module feature module, which contains the core Angular features required for a web application. The declarations property tells Angular that it should load the root component. The providers property tells Angular about the shared objects used by the application. And the bootstrap property tells Angular that the root component is the app component class. The next piece of plumbing is the bootstrap file, which starts the application. This tutorial is focused on using Angular to create applications that work in web browsers, but the Angular platform can be ported to different environments. The bootstrap file uses the Angular browser platform to load the root module and start the application. No changes are required for the content of the main.ts file, which is in the SportsStore/src folder. The development tool detects the changes to the projects file, compile the code files, and automatically reload the browser, producing the content as showing here. The best place to start any new project is the data model. I want to get to the point where you can see some Angular features at work. So rather than define the data model from end to end, I'm going to put some basic functionality in place using dummy data. I will use this data to create user-facing features and then return to the data model to wire it up to the RESTful web service. Every data model needs classes that describes the type of data that will be contained in the data model. For the SportsStore application, this means classes that describe the products sold in the store and the orders that are received from customers. Being able to describe products will be enough to get started with the SportsStore application. And I will create other model classes to support features as I implement them. I created a file called product.model.ts in the SportsStore/src/app/model folder and added the code as shown. The product class defines a constructor that accepts ID, name, category, description, and price properties, which correspond to the structure of the data used to populate the RESTful web service. The question marks that follow the parameter names indicate that these are optional parameters that can be omitted when creating new objects using the product class, which can be useful when writing applications where model object properties will be populated using HTML forms. To prepare for the transition from dummy to real data, I am going to feed the application data using a data source. The rest of the application won't know where the data is coming from, which will make the switch to getting data using HTTP request seamless. I added a file called static.datasource.ts to the SportsStore/src/app/model folder and defined the class as shown. The static data source class defines a method called getProducts, which returns the dummy data. The result of calling the getProducts method is an observable product, which is an observable that produces arrays of product objects. The observable class is provided by the reactive extensions package, which is used by Angular to handle state changes in applications, as described in Chapter 4. An observable object represents an asynchronous task that will be produce a result at some point in the future. Angular exposes its use of observable objects for some features, including making HTTP request, and this is why the getProducts method returns an observable product rather than simply returning the data synchronously. The @injectable decorator has been applied to the static data source class. This decorator is used to tell Angular that this class will be used as a service, which allows other classes to access its functionality through a feature called dependency injection, which we will describe in chapter 17 and 18. The data source is responsible for providing the application with the data it requires, but access to that data is typically mediated by a repository, which is responsible for distributing that data to individual application building blocks so that the details of how the data has been obtained are kept hidden. I added a file called product.repository.ts in the SportsStore/src/app/model folder and defined the class as shown here. When Angular needs to create a new instance of the repository, it will inspect the class and see that it needs a static data source object to invoke the product repository constructor and create a new object. The repository constructor calls the data source's getProducts method and then uses the subscribe method on the observable object, and that is returned to receive the product data. I added a file called model.module.ts in the SportsStore/src/app/model folder and defined the class shown here. The @ng module decorator is used to create feature modules, and its properties tell Angular how the module should be used. There is only one property in this module, providers, and it tells Angular which classes should be used as services for the dependency injection feature. Now that the data model is in place, I can start to build out the store functionality, which will let the user see the products for sale and place orders for them. The basic structure of the store will be a 2-column layout with category buttons that allow the list of products to be filtered and a table that contains the list of products. In the sections that follow, I will use Angular features and the data in the model to create the layout shown in the figure. As you become familiar with Angular, you will learn that features can be combined to solve the same problem in different ways. I try to introduce some variety into the SportsStore project to showcase some important Angular features. But I am going to keep things simple for the moment in the interest of being able to get the project started quickly. With this in mind, the starting point for the store functionality will be a new component, which is a class that provides data and logic to an HTML template, which contains data bindings that generate content dynamically. I created a file called store.component.ts in the SportsStore/src/app/store folder and defined the class as shown. The @component decorator has been applied to the store component class, which tells Angular that it is a component. The decorator's properties tell Angular how to apply the component to HTML content and how to find the component's template. The store component class provides the logic that will support the template content. The constructor receives the product repository object as an argument, provided through the dependency injection feature. The component defines products and categories properties that will be used to generate HTML content in the template, using data obtained from the repository. To provide the component with its template, I created a file called store.component.html in the SportsStore/src/app/store folder and added the HTML content as shown here. The template is simple. Just to get started, most of the elements provide the structure for the store layout and apply some Bootstrap CSS classes. There are only 2 Angular data bindings at the moment, which are denoted by the AND characters. These are string interpolation bindings, and they tell Angular to evaluate the binding expression and insert the result into the element. The expressions in these bindings display the number of products and categories provided by the store component. There is not much store functionality in place yet, but even so, some additional work is required to wire it up to the rest of the application to create the Angular feature module for the store functionality. I created a file called store.module.ts in the sportsstore/src/app/store folder and added the code as shown. The @ng module decorator configures the module using the imports property to tell Angular that the store module depends on the model module as well as browser module and forms module, which contain the standard Angular features for web applications and for working with HTML form elements. The decorator uses the declarations property to tell Angular about the store component class, and the exports property tells Angular the class can be also used in other parts of the application, which is important because it will be used by the root module. Applying the basic model and store functionality requires updating the application's root module to import the two feature modules, and also requires updating the root module's template to add the HTML element to which the component in the store module will be applied. This listing shows the change to the root components template. The store element replaces the previous content in the root components template and corresponds to the value of the selector property of the @component decorator, as showing in this listing. And here, it shows the change required to the root module so that Angular loads the feature module that contains the store functionality. When you save the changes to the root module, Angular will have all the details it needs to load the application and display the content from the store module, as shown here. If you don't see the expected result, then stop the Angular development tools and use the ngserve command to start them again. This will repeat the build process for the project and should reflect the changes you have made. All the building blocks created in the previous section work together to display the admittedly simple content, which shows how many products there are and how many categories they fit into. The nature of Angular development begins with a slow start, as the foundation of the project is put in place and the basic building blocks are created. But once that's done, new features can be created relatively easily. In the sections that follow, I add features to the store so that the user can see the products and offer. The obvious place to start is to display details for the product so that the customer can see what's on offer. This listing adds HTML elements to the store components template with data bindings that generate content for each product provided by the component. Most of the elements control the layout and appearance of the content. The most important change is the addition of an Angular data binding expression. This is an example of a directive, which transforms the HTML element it is applied to. This specific directive is called ng4, and it transforms the div element by duplicating it for each object written by the component's product's property. Angular includes a range of built-in directives that perform the most commonly required tasks. As it duplicates the div element, the current object is assigned to a variable called product, which allows it to be referred to in other data bindings, such as this one, which inserts the value of the current product's name description property as the content of the div element. Not all data in an application's data model can be displayed directly to the user. Angular includes a feature called pipes, which are classes used to transform or prepare a data value for its use in a data binding. There are several built-in pipes including with Angular, including the currency pipe, which formats number values as currencies, like this. The syntax for applying pipes can be a little awkward, but the expression in this binding tells Angular to format the price property of the current product using the currency pipe. with the currency conventions from the United States. Save the changes to the template and you will see a list of the products in the data model displayed as a long list. Adding support for filtering the list of products by category requires preparing the store component so that it keeps track of which category the user wants to display and requires changing the way that data is retrieved to use that category. These changes are simple because they build on the foundation that took so long to create at the start of the chapter. The selected category property is assigned the user's choice of category and is used in the updated data method as an argument to the getProducts method, delegating the filtering to the data source. The change category method brings these two members together in a method that can be invoked when the user makes a category selection. This listing shows the corresponding changes to the components template to provide the user with the set of buttons that change the selected category and show which category has been picked. There are two new button elements in the template. The first is a home button and it has an event binding that invokes the components change category method when the button is clicked. No argument is provided to the method, which has the effect of setting the category to null and selecting all the products. The ng-for binding has been applied to the other button element with an expression that will repeat the element for each value in the array returned by the component's categories property. The button has a click event binding whose expression calls the change category method to select the current category, which will filter the products displayed to the user. There is also a class binding, which adds the button element to the active class when the category associated with the button is the selected category. This provides the user with visual feedback when the categories are filtered. Filtering the products by category has helped make the product list more manageable. But a more typical approach is to break the list into smaller sections and present each of them as a page, along with navigation buttons that move between the pages. This listing enhances the store component so that it keeps track of the current page and the number of items on a page. There are two new features in this listing. The first is the ability to get a page of products, and the second is to change the size of the pages, allowing the number of products that each page contains to be altered. There is an oddity that the component has to work around. There is a limitation in the built-in ng-for directive that Angular provides, which can generate content only for the objects in an array or a collection, rather than using a counter. Since I need to generate numbered page navigation buttons, this means I need to create an array that contains the numbers I need, like this. This statement creates a new array, fills it with the value 0, and then uses the map method to generate a new array with the number sequence. This works well enough to implement the pagination feature, but it feels awkward, and I demonstrate a better approach in the next section. Here this listing shows the changes to the store components template to implement the pagination feature. The new elements add a select element that allows the size of the page to be changed and a set of buttons that navigate through the product pages. The new elements have data bindings to wire them up to the properties and methods provided by the component. The result is a more manageable set of products, as showing here. The select element in this listing is populated with option elements that are statically defined rather than created using data from the component. One impact of this is that when the selected value is passed to the change page size method, it will be a string value, which is why the argument is passed to a number before being used to set the page size. Care must be taken when receiving data values from HTML elements to ensure they are of the expected type. TypeScript type annotations don't help in this situation because the data binding expression is evaluated at runtime, long after the TypeScript compiler has generated JavaScript code that does not contain the extra type information. In this section, I am going to create a custom directive so that I don't have to generate an array full of numbers to create the page navigation buttons. Angular provides a good range of built-in directives, but it is a simple process to create your own directives to solve problems that are specific to your application or to support features that the built-in directives don't have. I added a file called counter.directive.ts in the src/app/store folder and used it to define the class as showing in this listing. This is an example of a structural directive which is described in detail in chapter 14. This directive is applied to elements through a counter property and relies on special features that Angular provides for creating content repeatedly, just like the built-in ng4 directive. In this case, rather than yield each object in a collection, the custom directive yields a series of numbers that can be used to create the page navigation buttons. To use the directive, it must be added to the declarations property of its feature module, as showing here. Now that the directive has been registered, it can be used in the store components template to replace the ng4 directive. The new data binding relies on a property called page count to configure the custom directive. Here in this listing, I have replaced the array of numbers with a simple number that provides the expression value. There is no visual change to the SportsStore application, but this section has demonstrated that it is possible to supplement the built-in Angular functionality with custom code that is tailored to the needs of a specific project. In this chapter, I started the SportsStore project. The early part of the chapter was spent creating the foundation for the project, including creating the root building blocks for the application and starting working on the feature modules. Once the foundation was in place, I was able to rapidly add features to display the dummy model data to the user, add pagination, and filter the products by category. I finished the chapter by creating a custom directive to demonstrate how the built-in features provided by the Angular can be supplemented by custom code. And in the next chapter, I'm continuing to building the SportsStore application.